Students, welcome to today's lecture. Today we are going to discuss on X-ray radiography techniques that is used for a non-destructive testing of materials in order to find out different flaws and defects in the materials. So the learning outcome of this lecture is that at the end of this lecture, student will be able to explain the working principle of X-ray radiography, factors affecting image quality, and applications of X-ray radiography. The main content discussed here are introduction to X-ray radiography, working principle of X-ray radiograph, how the images are formed in the X-ray radiographic technique, and the factors affecting the image quality, and some applications in engineering field, and the summary of the lecture. Hello students, we all are familiar with the electromagnetic spectrum. When we are looking to the electromagnetic spectrum, we can see the X-rays. X-rays are a rays with a low wavelength, and it is having high frequency than visible lights. X-rays are invisible and highly penetrating electromagnetic radiations. So these X-rays are used for detection of internal flaws in materials. So X-ray radiography is a non-destructive technique that uses X-rays to view the internal structure of an object. It provides a non-invasive method to inspect and analyze the materials, components, and assemblies. The key characteristics of X-ray radiography is that it is a non-destructive technique. It means that it will not allow the material to break, or the material will not be damaged at the end of the process of material detection. And the second one is that it has high penetration rate, so it can easily reveal the internal features or internal flaws in the material. A contrast imaging technique is used to find out the material flaws. So the difference in material density and compositions are highlighted, and very good quality images are produced as a result of X-ray radiography. And we all know that for this process of X-rays, X-ray is required. So the X-rays are produced with the help of an X-ray tube. The main components in an X-ray tube is a source of electrons that is made up of tungsten. These tungsten electrons, when charged, releasing electrons. These electrons are proceeded towards a water-cooled target anode. So two things are required here. One, filament or cathode filament that will provide a source of electrons, and a target to hit the electrons. So when the electrons hit on the target, what will happen? The release of energy will happen. So the amount of energy that is released are having two forms. Some of the energies, or the most of the energies, is released in the form of heat energy, and some of the energies is released in the form of X-rays, and some in the form of gamma rays, depending upon the wavelength of the rays produced. A high voltage is provided between the anode and cathode to provide this much energy, or high energy X-rays and gamma rays. So when it is hitting, a very less part of this kinetic energy is converted into energy of radiation, or X-rays or gamma rays. These produced X-rays are allowed to fall on the material to be inspected. These X-rays will penetrate to the surface of the material, and it comes out of the other side of the material. This material, if it is having the flaws, or the X-rays interact with the material, and the attenuation of the X-rays that is coming out of the material depending upon the density and thickness of the material. So the flow areas or defective areas are having different densities than the bulk areas. So the defect areas will attenuate in different way. The images is formed in the radiographic films, or images is found in the radiographic film which is placed in a cassette, or it is nowadays it is displayed on a computer screen with the help of a digital detector such as phosphorus plate, or a flat panel detectors, or digital radiography. It is called digital radiography. So the photographic films, the conventional photographic films used for the purpose is made up of silver halides. So this material will undergo darkens on exposure to electromagnetic radiation. The amount of darkening depends upon the amount of radiation falling on it. The commonly used silver halide is silver bromide. The silver bromide particles interact with the X-rays, resulting in liberation of silver ions to form latent images. This slide explains the factors affecting the image quality. You can see a source of electrons or the source of X-rays that is falling on the surface of a material to be inspected. In this case, the OIDs present will be attenuated differently. So the OIDs is having presented in the form of either dark or light regions in the X-rays. The other regions will be having higher intensity. So the darkened area shows the flows areas. So the main thing is the magnification. The magnification will be very high so that we can focus on very less areas. The sharpness is the ability to find out this type of sharp corners or edges in this type of material. So if it is not exposing correctly, the corners will not be detected easily. Radiography density is another factor, that is the degree of darkness or blackening of radiography film of the image. That is a ratio of intensity of X-rays coming in and the intensity of radiation coming out of the material. So the contract is a different in densities in the two regions. The different in densities in the two region, the flow areas are having low density and other areas are having non-defective areas are having higher density. So this will give you the contrast and latitude of the film. So the range of sample thickness that can be recorded in a single exposure. So these are some of the factors that is affecting the image quality in the case of X-ray radiography. So some of the major uses of the X-ray radiographies are in order to find out the defects of materials. So it can be used for detection of internal flaws such as cracks, fractures, voids and inclusion. It can be also used for the analysis of a structural failure in aerospace industries. It can be used in the inspection of weld, especially in the shipbuilding. Welding plays a very big role. So in order to find out the porosity and slag quality of the weld, this type of non-destructive testing is very useful. It is also used for the dimensional analysis and measurement. It can be used for composite material. Composite material are very important nowadays because composite material have been replaced by most of the material metallic materials. So the main problem with the composite material is the delamination and fiber orientation. So in order to find out the delamination and fiber orientation, we are using non-destructive testing such as X-ray radiography. So in the manufacturing of PCB and semiconductor also we use uh, this technique in order to find out the component inspection and flows. As a summary for this lecture, today we have discussed on the X-ray radiography and we found that X-ray radiography is a promising non-destructive testing technique for detecting the defects in materials, casting, welding, etc. So images are formed on X-rays, formed by the X-rays, imaging on the material to be examined. So the images are formed either on radiography films placed in a cassette or in a digital form in computer screens. The image quality is affected by different factors like contrast, sharpness, etc. that we already discussed. And it is having a lot of application in shipbuilding, aerospace industries, composite materials, electronic manufacturing, etc. So these are some of the references for the further readings. You can go through the non-destructive testing by Louis Cards ASM International, non-destructive evaluation and quality control ASM handbook, and you can also use this link given in this slide to refer much more on non-destructive testing as well as X-ray radiography. Thank you for watching this video. If you have any question, you can add in the comment boxes. Thank you. A small question regarding the lecture is also given here. You can answer these questions. If you are interested in answering, you can give the feedback or responses. The form is open to everyone. Thank you for listening.